So notice it says exponents and radicals. That's a lot to do in one day, so I split it up. We're going to do the exponent part today. Monday we'll do all the radical work. So we're just focused on the exponents right now. All right, exponential notation. You know this. If a is the real number, n's positive, then the nth power of a to the n. Let's fill this in here. Now, so what they're asking you are all these crazy variables in here is just realize the expansion. If I had x to the 7th, x times x times x times x times x, I lost track till you get to 7, okay? So in this case, you would have a times a times a times, and I'm just going to dot, 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 because we don't know what n is, however many of them there are. Well, vocab for you, a is called the base, and n is called the exponent, or the power. Usually you refer to it as the exponent. All right, so like I said, I'm going to, of course, go through the why on some of these problems, but you'll see some patterns and some shortcuts that you can make these pretty short and sweet without a lot of work on them. So evaluate the following. So if this was old school Algebra 1, that sounds like forever ago, I would make them write out, regretting 5. So there's our 5 1/2. And then you would multiply that out. So the top I'm going to do 1 times, what's 2 times 2 times 2 times 2 times 2? 32. Now I find that super obnoxious. And I'm guessing you probably did too. Again, I regret that 5 for an exponent on it. Remember, shortcut, we're all about the shortcuts in here. The 5, of course, applies to everything. So I don't really go old school Algebra 1. I'm just like, okay, what's 1 to the 5th? We got a 2 to the 5th. But that's the why behind it. You can use the shortcuts. The power applies to everything in the parentheses. So I would probably look at the bottom. Now again, if I was teaching this Algebra 1 style, we would do -3 times -3 times -3. But in here, we probably can, short and sweet, we know we're going to have 4 negatives, clearly. 4 negatives yields what for a sign? Positive. I'm not going to write a positive. What's 3 to the 4th power? 81. Good. So would I write any work on this realistically in here, or would I just slap down 81? Just put down 81. Okay. What's different about C from B to C? It's not in parentheses. So my final answer, is it going to be positive or negative? Negative. So just be conscientious of the signs. That's all that's telling you. So again, nothing too crazy. I think you know most of this, but good review, good review. I don't know how carried away they get with exponents back in your Algebra 1. All right, some more things, like I said, we already know. I threw that on the board over there from our true-false problems. We know anything to the 0 power. Let's go ahead and fill that in. That's nice and easy. And then we're going to talk about, of course, the negative exponents, which we did a little bit on our true-false. Now, when you get to a negative exponent, think of it in fraction form. All about fractions. So if I wrote this in fraction, of course, it'd be over 1. So anytime you cross a fraction bar, really the shortcut is, you can change the sign on the exponent. So really I'm in the numerator, so I'm going to put it in the denominator, and then I can change it to a positive n. So I just think if I need to change the sign on the exponent, I just switch the location. That's the bottom, I go to the top. Top, I go to the bottom. That's as wild. Negative exponents sometimes get kids, that's as wild as they are. All right, A, I don't even know why A is on here. That's too easy. It's 1. We all know it's 1. Let's just do it. Okay, x to the negative first. We want to write it with a positive exponent. Technically, it's in a numerator, so I'm going to flip it and put that in the denominator. Now, do you technically need this bottom 1, or could you just put 1 over x? 1 over x is fine. Just make it look a little prettier there. Okay, -2 to the -3rd power. Now again, it's that -3rd power that I don't love. So I'm going to flip these, and then I can make the 3 positive. Well, let's calculate out -2 cubed in the bottom. What's -2 cubed? -8. Ooh, that scared me. All right, usually you do not leave a negative in the denominator of a fraction. It's just one of those unwritten algebraic rules. So I'm just going to kick the negative out front and put my final answer as negative 1/8. Got it. So I wasn't too worried about the -2. It was that -3 exponent we had to be careful of. Now, the next thing, the chart, of course, there's nothing for you to fill in. I just copied it on here for you. It's really a summary of what's up on here on the whiteboard for you, all the exponent properties. So we already kind of talked about when you multiply, you add. We've already talked about our fractions, power to power. You multiply your exponents. Of course, any exponent outside, we've already talked about that. You apply it to everything inside. And here they're just showing you negative exponent on the top, it moved to the bottom. Bottom moved to the top. So it's just a quick summary of all the different exponent properties we've just kind of been talking about and looking at on the board, just for the record. All right, glance it over. Any questions on the front page? Love it. Okay, let's get into some better stuff here. A little more challenging. These aren't too bad. We're going to kind of work our way up. So multiplying, of course. Now, if this is algebra 1, if it's not, I'd make them right up. X times X times X times X. Times X times X times X times X, blah, 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 blah. Write them all out and expand it. Well, we're just going to use our shortcuts. 4, 7, we're going to have a total of 11. Okay, choices on how you attack this one. And there's no wrong way to do it. Couple ways you could do it. I'm going to show you both. You pick your poison. I could just, like the last one, like A, add these together. Of course, now I've got the little glitch with the negative exponent, so I'm thinking about it fraction form. I'm going to move it from the top to the bottom. I'm going to flip it and make it 1 over y cubed. Now, just to show you another version, another way to do it, if this makes more sense to you, and I don't care if you write both ways on your notes or not. The other way, I'm like, ooh, I could go, as soon as I see the negative exponent, I could think fraction style first, and I could kick this down to the bottom right away. And then I can just reduce the y's out. There's more y's in the bottom, so our y is going to stay down there. 7 minus 4 is going to give you the 3. So whatever makes more sense on how you want to tackle that doesn't matter to me. All right, nice, no negative exponents. There's more c's in the top, so I know my c answer will stay in the numerator. How many c's are we going to be left with once you simplify? 4. 9 minus 5, 4. Got it. Too easy. Let's kick it up here a little bit. Still not that bad. Okay, just make sure you cube everything in the parentheses on the first one. 3 cubed, 3 times 3 times 3. And we're going to cube the x. Like it. Same thing for f. We're just going to raise this everything to the 5th. What's 2 to the 5th power? 32. Okay. Too easy. Let's get into something a little more complicated here. Not that these are crazy, but obviously you have more variables, more powers, etc. So again, just one thing at a time. So the first thing I always look for is a power outside the parentheses. So I'm like, ooh, okay, I'm just going to cube everything back here first, and then I'll kind of see where we're at. So I'm just going to write this guy down for now and leave it. Just let him hang out. And I'm going to get that 3 out of the outside, and let's just cube it all. So 3 cubed, a cubed, b to the 4th, cube, power to power, let's multiply them. And now I'm just going to multiply those together. So I'm going to do my 2 and 27, 2 times 27, 54. And then let's total it up. A cubed, there's a total of 6 a's, a to the 6th. B squared, b to the 12, total it up, 12 and 2, 14. That wasn't so bad, I guess. Looked bad from the beginning, but not too bad. Now, same thing on h. Yeah, we got the fractions. It's just more stuff, okay? So same thing. I always look for these exponents on the outside first. Let's apply all of those and see where we're at. So I'm going to have x cubed, y cubed. For dramatic emphasis, I know you know there's multiplication really between these two. I'll put the dot in there. Then I'm going to raise everything to the 4th. 2 times 4, 8. Bless you. X to the 4th, z to the 4th. So we do have some simplifying. I don't think it's going to be too bad when you have a lot of variables. I mean, 3 is not awful, but I just kind of work alphabetical. So I'm going to look at the x's first. fill in my fraction bar and see where we're at. So I'm going to do my x's. X cubed, x to the 4th, they're both in the top. I'm just going to total them together. 3 and 4, 7. I'm going to look at my y's. So I've got y to the 8th, y cubed. Now, y cube's on the bottom, obviously. So we're going to simplify. There's more 8's in the top. Y is going to stay in the top. And then I subtract my exponents. 8 minus 3. And poor z to the 4th doesn't have any friends to simplify with, so he's just, I know, it's sad, it's rough. He's just hanging out on the bottom, crying himself to sleep at night. So any questions on that? Poor z. All right. Getting a little more challenging. Why do I use t? T's always look like pluses when I write them. Okay, so some negative exponents. So we're not going to get crazy, one step at a time. First thing is I go to simplify this. Let's start with the easy part. What's 6 over 2? 3. So I'm not going to put 3 over 1. I'm just going to leave it 3 on the top. Now, some of you can do this probably and go right to the final answer in your head, which is totally fine. I am going to put an intermediate step of work here. So I'm going to leave my s that's up there. That's not offensive. That doesn't have a negative exponent. But I see there's this s to the negative 2nd on the bottom. I'm going to shove him up to the top, which lets me make its exponent a positive 2. And I will combine those s's. Some of you might already have done that right now. I'm going to skip this step. I don't care. That's fine. Okay, t squared, positive exponent. I'm going to leave the positive exponents. He's just hanging out where he is. And then this t to the negative 4, let's move him. So some of you, like I said, might have gone straight to the final answer. So I'm going to just total up my s's, s cubed, and then t to the 6. So I always probably show more work than you guys do. I can't help myself. All right, choices on how you do this one. I don't know if one's really better than the other. I'm going to show you both ways, because clearly the negative 2 is the problem. So let me kind of set up both ways and you pick your poison. So technically, if we use our exponent properties, we would apply the negative 2 to everything. I find this obnoxious. And then I would move these around and I'll get the final answer. Like I said, I kind of personally find that obnoxious, personally. I'm going to show you how I would probably do it. So if I want to change the negative 2 to a positive 2, remember, it's all about flipping the fraction to change the sign on the powers. I'm just going to flip the fraction right now. And then I can change that to a squared. Well, I can square pretty easy in my head. 3 times 2. You will get the same thing over on the red once you move everything. Once you move this to the it just takes you an extra step. I don't care which way you do it. The green is kind of a shortcut. And I'm all about less work if I can get away with it. All right, any questions on these? So last thing we're going to do with exponents before we get to scientific notation, some rational exponents or some fractions. So the rules are the same over here, whether you're adding or multiplying or subtracting. You just have to deal with the fractions. So we're multiplying our a's, of course, so add them up. Well, that's not too bad. What's 1/3 plus 7/3? 8/3. That's not so bad. And of course, I'm always going to try to reduce my fractions if I can. Okay, all the same variable. A lot of fifths. Fractions on here. So let's just make it a little simpler on us and not get too carried away. I'm going to first just combine the top. So 2/5, 7/5, I'm going to make that a 9/5. Now, same rules apply. You have more a's in the top. 9/5 is larger than 3/5. So I know a is going to stay in the numerator. I'm not going to put over 1. That just seems a waste of writing. And I'm going to subtract my exponents. What's 9/5 minus 3/5? 6/5. So I've taught you nothing new from the beginning problems. We just have to deal with these crazy fraction / rational exponents. Okay, all right. So 3/2 on the outside. So just like when we started, I'm going to apply 3/2 to everything in the parentheses. So I'm going to have 2 to the 3/2. I'm going to work on A. Now, power to power, here we go, fraction masters. You're going to multiply those together. What's 3 times 3/2? 9 halves. Seems weird, but whatever. What's 4 times 3 halves? 6. That one comes out nice. 12 halves, 6. I feel like my B and the 6 look the same. Need better handwriting. All right, let's do D. D's a winner. We've got rational exponents, we got negatives, we got it all, okay? So again, same thing, I always look for that power on the outside. I'm going to apply that cubed first to everything and just see where we're at. So I'm going to do 2 cubed in my head. Got it. 3/4 times 3. 3 times 3, 9. 1/3 times 3. Oh, I like that. What's 1/3 times 3? 1. I'm not going to write a 1. We know it's a 1. And then I'm just going to leave this guy alone. But I'm going to work smarter, not harder. I'm not going to leave that x to the negative half on the bottom. Really, where is it going to need to end up? Top, because it's got that negative exponent, so let's just put it up there. And I'm just going to throw a placeholder in, just so we have it in fraction form. Okay, let's see what we can put together here. 8's 8. 8's just hanging out. Let's put our x's together. Oh man, we're going to have to do some fraction work. What's 9/4 plus 1/2? 9/4 plus 1/2. I'm not saying it. 9/4 plus 1/2. So 1/2 is equivalent to how many fourths?
2.
So 9/4 plus 2/4 makes 11/4. Okay, last thing we got to do are the y's. First question, in your final answer, where is y going to be located? In the top or the bottom? Top, there's more y's on the top, and we're going to have how many up there? 3, because we're going to reduce 1 out. So really, I don't need the fraction bar. Obviously, there's 1 on the bottom, so I'm just going to kind of use it to circle my answer. So I'm going to get creative there. All right, that's probably the toughest one of the day. Any questions on all the crazy exponent properties? Now remember, you can use your calculator if you need to on the fractions. I'd rather have you get the fraction work right if you got to double check it. So last thing we're going to talk about when we get into exponents, a little scientific notation. At the end, I'm going to show you, of course, how you can type some of this into your calculator if you want to, just to make it a little bit easier on you. So scientific notation, you probably see this in chemistry class, I would think, quite a bit. When you have those really, really, really big numbers, you don't want to have to keep writing those really large numbers out. It gets pretty obnoxious pretty quickly. So that's where scientific notation comes into play. Now, rules or reminders on scientific notation. This first number, which they're just using a right here for a little variable to hold the place, has to be between 1 and 10. So just be conscientious of that. So what they're referencing, the 4 has to be between 1 and 10. 1.66, obviously between 1 and 10. Okay, so I don't know why I picked 11. I regret it. So if we pick 11 decimal places. So remember, your decimal technically right now is right here. I try to fill it in on the right side of 4. When you are doing times 11, Lord help us, that moves the decimal place 11 places to the right. Regret 11, hardcore. So we're going to end up with a lot of zeros behind our 4. That's right. I might need a bigger blank. The question is, how many zeros am I going to have? Yeah, okay. I don't know if I'm going to fit it. 3, 4, 5, 6. I did. I had to write pretty small. I was getting worried about that one. I don't know why I picked such big numbers. Okay, negative exponent, the decimal place moves left. So here we are between the 1 and the 6. So I'm going to have it 1, 2, 3, 4, 5, 6, 7, 8. So how many zeros in front of the 1?
7.
Yeah, I'm regretting these big numbers. Okay. So I'm assuming you've done scientific notation. So let's just practice writing some of the numbers, converting from decimal form to scientific notation and vice versa. And we'll use our calculators. So this one's not too bad at all because you're really looking at how many zeros you have. We only have 1 on this one. So I'm really just ignoring it and I'm zeroed in, focused in on those first 4 digits. I'm going to write it between 1 and 10. So I'm going to make it 5.692. So now I just have to count how many decimal places. So I put it between the 5 and the 6 to get to the end. 1, 2, 3, 4. So I'm going to say times 10 to the 4th. Easy enough. Okay, ignore the decimals, or the zeros. We're going to put our decimal between the 9 and 3. And then I'm just going to have to count here quickly between 9 and 3 to the original one here on the left. 1, 2, 3, 4, 5. But the 5 means what sign on it? Negative, because you moved left. Good work. I like it. All right, let's do a couple more. Okay, we're going the opposite. So write each number in decimal notation. So they want you to expand it. So again, I regret using these big exponents. So we're going to move it 9 to the right. So 1, 2, and then how many zeros are you going to need? 7, yeah. 5, 6, 7. Make sure I got them all on there. Okay, this one we're moving, of course, 6 to the left. So there's going to be 1 and then 5 zeros in front of it. I like those. There's really not much work to show. So last thing we're going to do is just kind of this little wordy weirdo problem on here. More so than anything, just so I don't know if you know how to do scientific notation on your calculator. So just I want to show you that really. So calculating with scientific notation, they give you those numbers A, B, and C. Use a calculator to approximate the quotient of AB over C. So this is what we're working on. Okay, all right, so let's first set it up. Now, one thing I don't like, decimal format, scientific notation. I do not like that we have a decimal form and scientific notation forms. I don't like the mix and match. So first thing I'm going to do here is I list these. I'm marking up my board here. Is I'm going to convert A into scientific notation just so they're all the same style. So I'm going to make this, I'm going to put the decimal there, 4.6 times 10. Let me count here. 1, 2, 3, 4, negative 5. Got it. So we're going to do A times B over C. Okay, so you can straight type this into your calculator just as it appears. You could do it, not anything, any fancy things or anything different to it. You could just do all the numbers together and then figure out your exponent on 10 with your exponent properties. I didn't know if you know, I'll put this down here quick, this EE button. If you knew what that was on your calculator, that is scientific notation. So if I wanted to put this in and I'm too lazy to type the times 10 to the negative 5th, okay, so I could put in 4.6, I can hit that EE button, I gotta hit second and the comma key. The E does the default times 10 for me. That just saves me some keystrokes if I'm feeling lazy. Then I'm gonna hit times. I'm just doing the top, so 1.697. And then my EE button. I hate typing on this thing. And that power was 22. So that's what your numerator answer would be. I still have to divide it off by the bottom, which was 2.91 EE. And the power on the 10 in the denominator was negative 18. I swear I hit it. Come on, board. So there you got it. 2.68. The E means times 10 to the 35th power. I'm not going to write out all the 6825. No. Let's just go 6825. So I'm going to put 2.6825. 2.6825 times 10. I already forgot it. What was it? 35? Yeah. Ooh, 35. So I just really, more than anything, wanted to point out that EE button to you, just as really a keystroke saver. You can physically type it in, what is written in red up here, and it will give it to you. It will also crank that answer out. But just recognize that E. Plus, you're going to see when we do some bigger numbers and random things, it'll put it automatically in scientific notation. Your calculator will do that for you. So when you see that E button, or E pop up on your display, you need to recognize that means times 10. You never write E on your answer sheet, okay? You have to recognize that really means the times 10. Any questions on your calculators, how to punch that in? Everybody got it?